Today we are going to go over 8.9 part 2, operations with power series, and how to find the power series by integration. So the operations, here are some properties. Given fx is sigma a n times x to the n, and another function g of x equals bn times x to the n. If we want to find f of k of x, we just replace this x using k times x. If we want to find x to the mth power, we just plug x using x to the mth power. The sum or difference of two functions equal to the sigma notation, the sum and difference of these two series. And sometimes the interval of convergence might be a little bit different. We have to be very careful here. So let's have a look at some examples. Given 1 over 1 plus x equals sigma notation n from 0 to infinity, negative 1 to the n, x to the n. Find the following: 1 over 1 plus x and 1 over 1 minus x here. So we just replace the x here using negative x. So we plug negative x in to the nth power. Similarly, 1 over 1 plus x cubed, we just replace the x using negative 1 to the n, x to the 3 to the nth power. So next problem, negative 1 plus x to the negative 2 equals 1 plus x to the squared. So this is the derivative of the original function. So we take the derivative of this function. We treat all the n's as constants. So this gives us negative 1 to the n times x to the n minus 1 here. Because this original series r is negative x, so absolute value of x less than 1, x is between negative 1 and 1. Once it's open, all the derivatives is open, r stays the same. But when we take the antiderivative, for example, ln of x, 1 plus x equals antiderivative. So this equals, we plug this sigma in, give us sigma notation, negative 1 to the n times x to the n plus 1 over n plus 1 plus constant c. So now we have to solve for constant c. We are going to plug in center, x equals 0. So the left is this, right is here. So left ln 1 equals, when we plug 0 in, the sigma notation here is 0 plus c. ln 1 is 0, so c equals 0. So this gives us 1 plus x, ln 1 plus x equals sigma. So because 1 over 1 plus x is open interval, negative 1 to 1. So the upper levels, we have to check the two endpoints, x equals 1, x equals negative 1. We plug it in. When x equals 1, it's negative n, 1 to the nth power over n plus 1. So this is the alternating series. So three conditions satisfied. So converges. This one, when we plug negative 1 in, so it's negative 1 to the n times negative 1 to the n plus 1 over n plus 1, give us negative 1 to the 2n plus 1, which is always negative 1 here. So diverges. So our interval convergence will be negative 1 open and 1 closed here. And r stay the same, r equals 1. Let's have a look at the next example. Find the power series by integration here. So given fx, as we know, the derivative of arctangent is 1 over 1 plus x squared. So f of x will be integration 1 over 1 plus x squared dx here. So this gives us, so a equals 1, r equals negative x squared. Sigma notation is from 0 to infinity, a times r to the nth power. Give us negative 1 to the n, x to the 2n power. So as negative x squared less than 1, so x squared less than 1. So x is less than 1. So the interval negative 1 to 1. This is the interval for this function. So now we're taking the antiderivative of this. So this will give us sigma notation, 0 to infinity, -1 to the n, x to the 2n plus 1 over 2n plus 1 plus constant c. Let me move this here. So now we have to solve for c now. We plug in the center, c equals 0 in. So the left side is arctangent. So arctangent of 0 equals 0 plus c. So c equals 0. So that means arctangent of x equals sigma notation, n equals 0 to infinity, -1 to the n. Now we have to look at the boundaries now. At x equals 1 and -1, we plug it in. Sigma. This one converges. And when we plug -1 in, -1 to the n, -1 to the 2n plus 1 over 2n plus 1. Because this is always going to be -1, because it's to the odd power, so it's -1 to the n plus 1 over 2n plus 1. Also alternating series converges here. So -1 to 1, close the interval. So next problem, you can try it yourself. However, as we know, g of x equals Ln of x, which is integration 1 over x dx. We want to center at 2 now. We have to rewrite it as x minus 2 plus 2 dx. Now we divide by 2 and simplify it. You can do it yourself and compare your answer with mine. Here's my answer key for the problem number 2. This is how do you simplify. We want x minus c to the n power here. So we write it this way, and we take the antiderivative. Solve for constant c, not a 0 anymore. R equals 2, check the boundaries. Look at the algebra here, it's a little bit tedious. Final answer right here.